Okay, so here we have the indefinite integral of sine to the power of 4 of x times cosine of x dx, and I can see immediately that this is a great candidate for u substitution because I have a function which is being raised to some power, the sine here, and then I'm multiplying immediately by its derivative, cosine. And this allows me to of course simplify by doing this substitution. U is equal to sine of x. We're always setting the function whose derivative we're multiplying by to be the u, because that gives us then du by dx is equal to cosine of x, and then we can rearrange and say du is equal to cosine of x dx, where we think about this as multiplying through by the dx, even though that's not actually what's going on. And so this, after we make these substitutions, let me just make sure our colors are coordinated here. The cosine of x times dx is our du, and our u is sine of x. This allows me to now rewrite this thing as, whoops, I'll make it a little bit nicer maybe, u to the power of 4, integral of u to the power of 4 du, which of course is u to the power of 5 over 5 plus an arbitrary constant, working backward from the power rule. And the last step is that I resubstitute in the sine of x for the u, because after all, I was asked to find the antiderivative of a function of x. I can't give a function of u, it has to be a function of x. So I unsubstitute at the end, and if we want, we can check that this is actually the correct antiderivative. If you take the derivative, the 5 comes down and cancels with the 5. We get a sine to the 4. The constant goes away, and by the chain rule, we're multiplying the sine to the power of 4x by cosine of x.